everybody, and welcome back to another video. In today's video, we'll be talking about the polar coordinate system. Now, when we talk about coordinate system, it essentially refers to the system of x and y plane. So, like we have two-dimensional plane, and we want to mark every point. So, we know of that, right? Let's just draw a y-axis, a little y-axis for reference, and then let us draw an x-axis. Let me try to keep that in the same page. If that is the y-axis, then this is the x-axis, and we can mark, if I have the red color over here, then we can mark this to be the y-axis, and we can mark this to be the x-axis, and we can mark points on this plane as we are well aware of. So if, let's say, if this is x1, if this is y1, if this distance, so to say, is y2, and if this is x2, then we can name this point to be x1. That was a very weird looking x, so let me write that properly. X1 comma y1, and we can name this point as x2 comma y2. Put a y in between, put a comma in between. So, right, this distance is x2 and this distance is y2. So it goes x2 units to the right and y2 units up. Similarly, this point, it goes x1 units to the right and y1 units up. We do know that right direction is positive in terms of x-axis, and up direction is also positive in terms of y-axis. So this is the coordinate system that we are well aware of. Now, we can represent these set of points in different ways. So if this is one system of representing these points, we have another system of representing these points, these similar points, using the polar coordinate system. So what is the polar coordinate system all about? Essentially, the polar coordinate system uses the concept of unit circle. So it essentially talks about a circle which has radius 1 unit, and we use properties of properties of trigonometry to determine the location of certain points on the x and y plane. So if I'm talking about a unit circle, the first thing that I'll need is a circle whose center can be assumed to coincide with the origin of the plane that I'm talking about. So if this is the origin of the plane, the two-dimensional plane, it will also coincide with the center of the circle. This circle that I'm talking about, the center of the circle also lies on this point. Now, unit circle. So if this is a unit circle, I'm saying that this circle is actually a unit circle. So as I mentioned before, if it's a unit circle, the most important let's say property of the circle is that the radius of the circle is 1 unit. Now, what do I mean by 1 unit? Is it 1 centimeter? Is it 1 meter? Is it 1 millimeter? Is it 1 inch? That particularly is of not any substantial relevance to the explanation. So it can be any unit you want, but it needs to be 1 unit. So if you like centimeter, it's 1 centimeter. If you like inches, it's 1 inch. If you can see 1 millimeter, it's 1 millimeter. That is of no concern to us. It's just 1 unit. So this is a unit circle if the radius of this circle is 1 unit. That is r equal to 1, right? Now, the next thing that we'll be doing is, let's say I want to measure or ascertain the location of this point on the circumference of a circle. Now, you might be asking, why do I want to measure a point which is on the circumference of the circle? It could have been a point over here, it could have been a point over here, right? Well, if you had asked me to find out the location of this circle, I would have drawn a circle whose circumference goes through this point, and then I would have said, let me assume that the radius of that circle that I consider has 1 unit radius, right? whatever point you give me, I will be drawing a circle through that point and make sure that the radius of that particular circle is assumed to be 1 unit. So it doesn't actually need to be 1 centimeter as well. I can say that, let's say 1.7 centimeter is 1 unit. It doesn't need to be a standard unit. It can be any unit I want. I can say that 1 unit, for this explanation, I can say 1 unit is 1.634 centimeter. So that is why I said unit is of no concern. So let's say that the point that you have asked me is right here, and very neatly I drew a circle whose circumference passes through this point, right? So now I need to ascertain the location or the position of this point with respect to the origin, right? Of course, because every location is determined on the basis of one particular focus point or one particular reference point of reference, right? So let's say up until now, based on the coordinate system that we know of, the location of this point is a comma b. Let's say this is up until now the location that we know of, and I want to find out the location of the same point in terms of the polar coordinate system. So what I'll be doing is, the first thing that I'll be doing is I'll be connecting this point to the center of a circle. So that is the first thing that I'll be doing. Next, you might take a different color or you might not. I'll be trying to find out the angle subtended by this. So let's say this is theta, right? I'm saying that this arc subtends the angle theta at the center of a circle. So now I'll be trying to bring in the concept of trigonometry. Now, how do I bring in the concept of trigonometry? Let's say I draw a straight line from the point of concern. So the point that you had given me, the AB point, let's call this point A. This is the point A. So I'll be dropping a perpendicular from point A on the x-axis. So if this is the x-axis and this is the y-axis, I'll be dropping a perpendicular from point A to the x-axis. So if it's perpendicular, that this is naturally 90 degree, and so is this angle. So if this is the origin O and if this is A, let me call this B. So this point is B, and I can say that angle ABO is also 90 degree. Now I'll be bringing in the concept of trigonometry. Note that if this point is C, then OC, as I had mentioned before, is 1 unit. But this line OA, this is also the radius of a circle, right? If OC is a radius, so is OA. OA is also the radius of a circle. So if OC is of length 1 unit, we know that the radius of a circle is a constant number for a particular circle, right? So this distance should also be 1 unit. If OC is 1 unit, then so should OAB, right? OA is also 1 unit. So now what I'll be doing is, let me consider this triangle OAB. So let me consider triangle OAB, right? Now, what I'll be doing is, I'll be trying to bring in the concept of trigonometry, as I have mentioned before. Let's say I talk about cos theta. Cos theta. So this is the first trigonometric angle trigonometric ratio rather, that I'll be thinking of. Now, we know cos theta is base by hypotenuse. So if I think about base by hypotenuse, what will it be? It will be OB, that's the base, and hypotenuse will be OA. So I can write cos theta to be OB by OA, right? This will be OB and this will be OA. Now let me try to find out what these actually are. OB. If I'm thinking about this point has been set to have the location A comma B. If that is true, then doesn't that essentially mean that I have moved A points to the right from the origin and then went B units up? I went A units from the origin right, and then I've moved B units up. So doesn't that mean that OB is of length A. So this length OB is A units, this much, not up till to the radius. Let me mark that, or maybe let me just use dotted line. So this distance is A, and this distance, let me just use a single straight line, and this length is B up until this point. So this distance is A units, and this distance is B units. So OB is actually A, right? So I can replace OB with A. Now, just a while back, I said that OA, being the radius of a unit circle that I've considered, should be of length 1. So the denominator is actually 1. OA is 1, which means I can say cos theta is just A. It's just simply A. Again, if I'm talking about sine theta, let's talk about sine theta now. I've talked about cos theta, so let me talk about sine theta now. If I talk about sine theta, what is sine theta all about? Sine theta is perpendicular by hypotenuse. So if I'm talking about perpendicular by hypotenuse, that would be AB by OA. Now, if you might be wondering, okay, so the OA part will again become 1, right? So you're correct. Let me write that down. AB by OA. So that's AB by OA. Now the denominator, again, we are well aware that OA will turn out to be 1. So we'll have just a single number on the numerator. Now what's the numerator now? Again, we just discussed that OB is A, and from the point B, we went up by distance B, right? We went up by distance B. This distance is B. So this distance, AB, is B units, as I have mentioned here. So this AB is actually B. Now, if you look closely, I have the system that I was aware of, the normal coordinate system, the location gave me A comma B. I have represented A in terms of cos theta and B in terms of sine theta. So, can I not represent this system if I turn back to the color that I was using initially? Can I not write this as cos theta, comma, sine theta? Because I just said that for the unit circle, of course, for a unit circle, A is actually equal to cos theta, right? A is equal to cos theta and B is equal to sine theta. So I can replace A with cos theta and B with sine theta. That does not change any analysis. So essentially, every point which can be given a position in the normal coordinate system, the two-dimensional coordinate system, the xy plane, I can find a corresponding polar coordinate location for those points. And this is it essentially boils down to the fact that the angle subtended by the point with respect to the unit circle, like if I make all these constructions, then the angle subtended is of main concern because the radius will be of 1 unit. So this angle becomes the point of concern, and then we can replace the first of the ordered pair, the first letter of the ordered pair, the x coordinate, essentially the abscissa, to be cos theta and the ordinate to be sine theta. This order remains the same because we know that cos theta is OB by OA and sine theta is AB by OA. So it cannot be sine theta by cos theta. But for any other point that you can think of, let's say you take a point over here. If you do that, then we'll be able to draw a straight line as follows, and let's say this angle, let's say, is alpha. If that is true, then this point will have the coordinate system cos alpha, sine alpha. So this will have cos alpha. There isn't space, so I have to write it in the next line. Cos alpha, sine alpha. So any point that you can think of, in some cases you'll have to redraw the circle and redefine the unit length for the unit circle that I'm considering. And and after that, once you get that exercise done, you will be able to determine the location of that particular point that you are considering in terms of the polar coordinate system. This is called the polar coordinate system. This expressing the point in terms of cos theta and sine theta, this is called the polar coordinate system. So that concludes the method of determining the location of any point given in the usual coordinate system, the xy coordinate system, in terms of and expressing it in terms of the polar coordinate system.